everyone, my name is Iman, and on behalf of the co-authors Hussein, Muhammad, Ali, and Marwan, I will be presenting our work entitled Refactoring Practices in the Context of Modern Code Review, an industrial case study at Xerox. I want to start by giving a background of the company that we had this study in. Xerox has a software that's around 20 years old, lengthy and complex. Developers in charge have been successfully evolving it to meet business requirements. The software is directly connected to the hardware and performs various operations such as scanning, printing, and exchanging with the cloud services. The company has a research and development division that uses a collaborative code review framework, and the company provides secure and reliable functionality to the end users. In Xerox, the review process is as follows. Once developers have the review request, once it's open, there is someone who would be assigned to review the code. And if there is any revision requested, they keep revising it all the way to when the change is approved. One of our co-authors, who is actually working in the company for over 3 years, has noticed that his review, when he refactors the code, takes typically longer than usual to be approved. That motivated our study to investigate whether his hypothesis of refactoring review takes longer than usual is true or not. We did the following study design. We scan a lot of review request repositories for development team. We extract refactoring review and we found around 161 refactoring reviews. In order for us to be able to compare them properly to the other population, we randomly sample non-refactoring review, and we make sure that these randomly sample as close as possible to the refactoring reviews. We did that by picking reviews from a similar developer and similar timeline. We did realize that refactoring review takes longer to be completed, and the difference is found to be significant. It's true that refactoring review takes longer than non-refactoring review. We did one extra step to explore whether the discussion that takes place between the author of the review and the reviewer would also be longer between the refactoring review or not. Indeed, we found also that refactoring review triggers longer discussion between the code author and the reviewers before they reach consensus. And these two examples motivate our research goal. We designed this study to understand exactly what are the challenges that reviewers face when they are reviewing refactoring code, why reviewers and the authors take longer to reach consensus when it comes to reviewing refactoring code. The survey consisted of 11 questions that are divided into two parts. The first part of the survey includes demographic questions about the participant. The industrial experience of the respondents ranged from 1 to 35 years. The refactoring experience ranged from 1 to 30 years, and their experience in code review ranged from 1 to 25 years. In the second part of the survey, we ask about the motivation behind refactoring, the documentation of the refactoring changes, the challenges faced when reviewing refactoring, the verification of the refactoring changes, and finally, the implications of refactoring in code quality. For the first RQ, this figure shows developer intention when they refactor their code. The code small and backfix categories had the highest number of responses. The category functional was the third popular category for refactoring related commits, followed by internal and external quality attributes. However, we observed there was no dominant category. As for the second RQ, when we ask what information do you explicitly provide when documenting refactoring, 91% of developers indicated that they explicitly mention the motivation behind the application of refactoring, such as improving readability and eliminating code small. However, 34% of developers indicated their refactoring strategy by stating explicitly the type of refactoring operations they perform in the submitted code changes description, such as move a class. As for the third RQ, as shown in the figure, we report the main challenges faced by a reviewer when inspecting a refactoring review request. The majority of developers were concerned about avoiding the introduction of regression and system functionality. 58% revealed the need to investigate the impact of refactoring inequality. A moderate subset of developers were concerned about understanding the motivation for refactoring changes, whereas 41% were concerned about having inadequate documentation about refactoring. 37% found that reviewing refactoring changes in a timely manner is difficult, whereas 25% mentioned that the challenge is centered around understanding how refactoring changes were implemented. For the fourth RQ, developer reported the mechanism to verify the application of refactoring. 95% referred to the testing the refactored code, and 70% reported doing manual validation. 45% brought up ensuring the improvement of software quality metrics. 37% mentioned that using visualization technique, and 37% selected running static checkers and linters. As for the final RQ, as can be seen here, all participants reported that the code becomes more readable and understandable after the application of refactoring. 50% indicated that it becomes easier to pass the Sonar Cube quality gate, and 45% stated that expectation that the refactored code should reduce the code proneness to bug. Our main observation from developer responses is how the review process for refactoring is being hindered by the lack of documentation. Therefore, as part of our survey to the company, we designed a procedure for documenting any refactoring review, respecting the three dimensions that we refer to as 3 I's, namely intent, instruction, and impact. For intent, developers should state the motivation behind refactoring. For instruction, developers should report all refactoring operation applied. And for the impact, developers should state what the impact of the applied refactoring inequality. And here is an example. Developer mentioned that they want to remove a duplicate code. As for the instruction, developer mentioned all the steps needed to remove the duplicate code. And for the impact, developer mentioned that by removing duplicate code, they reduce the complexity of the code. Recommendation for research and education. For research, refactoring for readability was pointed out by the majority of participants. Reviewers are currently relying on their own interpretation to assess the readability improvement. So there is a need for refactoring our code readability metrics that specifically evaluate the code elements that were impacted by refactoring. Such metrics help in contextualizing the measurement to fulfill developer intention. As for the education, prospective software engineers are mainly taught how to model, develop, and maintain software. With the growth of software community, it's important to also teach the next generation of software engineers the best practice of refactoring documentation. That's the end of our presentation. If you are interested in our work, please visit our website. Thank you.
Okay, so we're live for the Q&A session. My name is Francisco Servant. I'm going to be the session chair for this Q&A today. And we have Iman Abdullah Alomar, who's going to answer your questions. So let's jump right into it. The first question is from Felipe. He's asking, in the pilot study, can you comment on the differences between refactoring and non-refactoring changes according to different characteristics, such as size, complexity, number of files affected, and also were the refactoring changes doing only refactoring or also a combination of other things?
Yeah, that's a good question. So for the refactoring and non-refactoring, so first of all, we consider the same criteria, which means that it's created between the same period of the year, from January to December, like for both refactoring and non-refactoring. This is one criteria. Second criteria is basically created by the set of authors of the refactoring review. And also the third criteria is created to update the same subsystem. So we make sure that when we compare both of them, the comparison is a bit fair. Um, with regard to size and complexity, I'm not sure. Like when you said complexity, this is part of the impact. So I'm not sure. I'm not sure about like what does it mean. Is it like the impact of these refactoring changes on equality? Um, I'm not sure about that part. But the second part, where the refactoring change is only addressing refactoring, no, I mean, it's considered like for everything, because part of our study is also to understand the motivation. And what we noticed that when we ask about the motivation, they said, okay, we are doing refactoring to fix bug, which consider like fixing a bug is part also of the refactoring changes that they are doing. Actually, one of the challenges that we found, they are saying that we are interleaving refactoring with other code changes, including fixing bug or adding feature and so on.
Okay, thank you. So the next question is more of a comment. You're just getting praised that it's good to have these empirical studies at a single company in context.
Oh, okay.
So congratulations on that.
Okay, thank you, Anish. Thank you for your comments.
So the next question is from Pooja Rani. I hope I said that right. So the question is, as you mentioned that one of the main intent of the code review is to improve the code quality, and they found that code quality is improved after the code review. Did you observe how reviewers ensure that case? And also, how did they verify that the new version of the code is better in terms of coding style and readability? Just by reading it, all the new version of the project, or were they using specific tools?
I see. That's also interesting questions. I'm trying to make sure that I answer all of the sub questions. So, did you observe that? How did the reviewer ensure that? So, in Xerox, they have a tool called, I think, similar to Sonar Cube. This tool indicate for them like whether the kind of like the quality has been improved. But part of our study, we want to just for the developer to also note down the potential impact in their review, so that the reviewer would expect also the impact of this kind of like changes. But for Xerox, they are using a tool like quality tool to ensure that the impact on the quality. Also, how did they verify that the new version of the code is better than in terms of the coding style and readability? I I don't think so. They are also measuring the readability in their context. I'm not sure about like yeah. I'm not sure about like what kind of like all of the quality attributes. Did they consider also only the internal quality attribute like complexity, size, etc., or also the external like readability stuff? But based on my observation, the reviewers are mentioning that, or the developers who are surveying, they are mentioning a lot. They want to improve the readability. They want to improve. They want to like do refactoring to improve the readability. Which means that they don't have a tool actually to measure the readability. And part of our suggestion is basically to kind of like make the refactoring research community to come up with a refactoring aware readability metrics in order to see the impact of these changes on the readability. So kind of like readability metrics is specific to refactoring. Um, so the last part is basically reading the old and the new version to a specific tool. I think this is the answer to the question by also like saying the tools that they are using. Yeah.
Thank you. So your next question is, if I were to replicate your work in one of my industrial or somebody else's industrial partners, what should they do differently?
Nice question again. So I would just want to highlight that in our study, we are not looking for generalizability. We are looking for a case study to understand the refactoring code review. So what I want to suggest, and what this is what I'm trying to explore right now, is basically to kind of also consider other company to see like, are they also having a lack of refactoring documentation? Did the review also take longer, review refactoring take longer than the non-refactoring review? So that we can also generalize kind of like the finding. This is one. The second one is basically we wanted the different thing that you maybe you can consider in the company is basically to apply the three I's that we are mentioning, which is the impact, intent, and instructions. So that so far we are suggesting this template, and upon acceptance for our trial at Xerox, a set of developers have adopted this procedures by submitting only refactoring changes. So what we want to do, we want to also test this template. We want to ask the developer, can you try this template and see whether reviewing refactoring would be improved and what we're not going to take some time or not. So this like this aspect, which is testing the template, is will be like I think additional thing that you need to do. For example, if you want to replicate my study, and besides testing it like to another company.
Great, thank you. So the next question is, well, first, nice talk. And
Thank you.
did you observe the need for an automated suggestion of refactoring? And if yes, would you think that the developers would like to see those suggestions as well as the rationale why they should refactor them?
The need for automated suggestion for refactoring. Um, so it's a bit like this is a question is a bit broad. Um, Automated suggestion for refactoring does that mean like for example similar to the current tool that we had, for example like refactoring recommendation like JDudrant or not. So of course I'm gonna suggest like the need for automated suggestion for refactoring. Um, would you think that developers would like to see the suggestion as well as the rationale why they are should refactor them? You mean does that mean in the tool? So I need some clarification for that. Um, because like part of the template, when I said that showing the intent, which is the rationale, is not part of the tool, is basically like maybe the end like the clarification for that part is not clear maybe. So in our studies, so we are not targeting like for example automating that refactoring part. I'm trying to emphasize on the need to have better documentation when you review the code, so that the review and refactor will not take that longer time compared to the non-refactored changes. So part of the study is, I said, yeah, we need to add the rationale, but that rationale or the impact is part of the documentation, just to make review and refactoring changes much better. But in general, yeah, I advocate for having automated suggestion for refactoring. But maybe like your question, maybe if it's like in the context of code review, I would be more than happy to expand on that maybe during the discussion room if I need some clarification about your part.
Thank you. So next question is, you mentioned that metrics such as readability should be adapted according to the code review domain. What would you change in the metric for that adaptation?
You mentioned that refactors such as readability should be adopted according to review domain. So what I was saying in here. So I'm not saying that readability metrics that we want to focus on refactoring is basically to only focus on code review. So the goal is basically to measure the impact on that. So even if the current readability metrics, like for current readability, we have some of them, right? And we are using them in the literature, but it's not specific for refactoring changes, like specifically. It's basically for general. What I want to say, because refactoring has different like kind of like practice compared to the other refactoring changes, we want to have maybe refactor code readability metrics that for example corresponding to measure for the certain code small. For example, like if I have this long method with a certain